Okay, I just want to do a really quick video about understanding a story problem. So here I've got a couple um, quick story problems just jotted down. I pulled the important information out. So here we have a savings account that was put in $1,000 into a high interest account that does 8% per year. And we get that account when we turn 18 years old. Let's say grandma made it when we were first born. Okay. So we have to create a geometric sequence out of this. So we have to pull out the fact that we know we have 8% interest that's going to get tacked onto that. Okay. Now, the thing to understand is that if we only, as our common ratio, make 8% as our common ratio, it's actually going to go down. Okay. 8% of 1,000 is 80, which would go down. So what we actually want is 108. So that we're taking the $1,000 that we start with and tacking on the 8% interest. So what we actually will have is 1,000, because it's our first term, multiplied by 1.08. Okay, we want to write that as decimal form. I suggest multiplying 1,000 by 0.08 and then by 1.08 so you can see the difference. And then you'll raise that to n minus 1. Now, we know that this account was created when we were born and that we get it becomes ours when we turn 18 years old. So what term is this? We have to remember that when it first started, that was we were 0 years old. 18 years old is 19, a spread of 19 terms. Okay. You may think that term 18 is the 18th term, but it's actually the 19th. If you want to think about it as when you were first born, you were 0 when that account was made. After 1 year, there was interest. Okay. That's term 2, but you're only 1 year old. After another year, the account is 3 years old, or excuse me, it's year 2, but we're on term 3. Okay. So when we get all the way out to 18 years old, it's actually term 19. So we would replace n with 18. I'm not going to do the rest of the calculation. I just want to get that. Okay. Same thing. We have 50 grams that's of a radioactive material. Okay. It's breaking down at a rate of 7% per month. I know it's not quite realistic, but it's breaking down at 7% per month. I want to know how much is left after a year. Now, you might think the same thing, except for the fact that it's going down. And so you might think 0.07% would be or 0.07 would be your common ratio. But you have to think about the fact that it's breaking down by 7%. And I want to know how much is going to be left. So I want to know how much is left after it's broken down. So if it's breaking down by 7% per month, what I'm actually going to have is 93% left. 50 grams, 7% breaks down, 100% take away 7%, you're left with 93%. So you always have 93% left after it breaks down. So that'll be 0.93. N minus 1, always n minus 1, and 50 is our first term. Okay, so this is our equation. After 1 year, we want to know how much is left after 1 year. Once again, it's very much like this first one, 1 year, and we're talking about months, so we want to know 12 months. But once again, at the beginning, it hasn't broken down yet. After the first month, it'll break down. So we actually want to know the 13th term, not the 12th, but the 13th. Okay? Because 50 is at our beginning. 1 month in, it breaks down. 1 month in, it breaks down. 1 month in, it breaks down. Okay? We want to know after 12 months of breakdown, which is the 13th term. Okay? Now, there are many of problems like this that are all logic based. You just have to think through it and find your real common ratio, find your real term, and you're typically given the first term.